so that people who will join us a bit late can just watch back whatever they have missed. Can everyone see my screen all right? Hello, is anyone there? Can everyone see the screen all right?
Yes.
Yes.
All right.
Yes, sir.
Okay, let's go. All right. All right. Good morning, guys. So today we'll be going through this environmental chemistry. So it's a very straightforward factual topic. It was chosen specifically because you guys are at home, and being a factual topic, it's actually quite easy to get the facts straightforward, and rather than something that will involve experiment or that kind of stuff. So these lecture notes have been printed out actually in the school. Some of you who were in school last Saturday already had the chance to collect the lecture notes as well as the associated work, but the one who didn't, you might have to actually copy down some of the notes so that you will have enough resources and materials for you to actually go through the work, the associated work. Yeah? Okay, so this is about chemistry of the environment. So the first bit we'll go through today is just on water. So we know water is very important. It's pouring outside. It's rainwater outside. I'm not sure, but you know that in some countries, the rainwater is not safe for drinking, right? Even seawater. Do we drink seawater? Let me ask a few people. Are you there, Andrew?
Yes.
You do geography, right? Do we like to drink seawater? Can we drink seawater straight away?
No.
Why not?
Pasaya ada salt dalam niya.
Oh, okay. Do we need salt, Azura? Do we need salt to survive, Azura? Are you there, Azura? Can Azura hear me? Is Kinawi there? I can't really see my gallery screen when I'm sharing that, so I'm not sure if Kinawi or Azura is there. Anyone there? Can you drink seawater? So Andrew said you can't drink seawater because it contains salt, right? But we like to drink 100+, which contains salt as well. So actually we do need salt to survive, but we can't drink straight from seawater because seawater contains a huge amount of salt that is not very good for you, in terms of the salt content in the body. So in terms of water, we can drink, well, we drink the water that has been treated from the water plant. I mean, we all live in Tutong. You all know about the Bukit Baru Water Treatment Plant Center. Not too sure about whether you know what they do at the water treatment plant. Well, they do one thing, they treat the water. A few months ago, people in Bandar actually had a problem with water supply. They look a bit like coffee. I'm not sure if you would drink water that looks like coffee coming out from the tap. I certainly wouldn't, but that is probably a result of the water coming out from the tap, where the tap is a bit rusty or the tap has got dirt or whatever inside. Anyway, the idea is that clean water is very, very important. So let's go through a couple of these learning objectives, as that's what the Cambridge curriculum expects you to be able to do. Okay, the first thing was actually straight from your year 9 syllabus. It was called distillation. So distillation is a separation technique, and it works because we are trying to separate liquids that have something that is different. Do you know what is the property of a specific liquid that make it suitable for you to do distillation? Is Balkis there? Are you there, Balkis?
Yes.
Balkis, what is the property that allows you to separate different liquids by this process of distillation? So if filtration is menapis, right, in Malay. So filtration works because something is soluble, something is insoluble. If you want to distill out alcohol and water, what makes you think you can use distillation to do that? What is different between the water and alcohol that allows you to separate these two by distillation?
It's dissolved.
Well, both of them are soluble in each other, right? So you can't do filtration. But what makes it suitable for you to separate them? Remember? Not really?
No.
Okay, well, that is your year 9 separation techniques. Actually, it works by the principle of different boiling point. So the idea is they must have different boiling points. we know that when you have water and alcohol, so water and alcohol can be separated out because they have different boiling point. And that is why you can get the alcohol before the water, because the alcohol will boil first before the water. We'll come back to that in a little bit. So distillation involves two processes. There's evaporation or boiling, and then you condense it together to get back the liquid there. So it's just the first learning objective there. In terms of why we use distilled water in the lab, I think I mentioned this before when we did a couple of rate of reaction experiments. So we always use distilled water straight from the bottle. We never go for the tap water because, for all we know, your tap water actually has some other stuff dissolved in it. Your tap water is basically treated water already. It's not pure 100% water. It's got something dissolved in it, and that's why it's got impurities. In terms of the first question asked Andrew just now, do we want to drink water straight from the river or straight from the sea or straight from rainwater? We can't really be sure that the rainwater is actually safe for consumption because you don't know what is inside your cloud. If you got a lot of air pollutants that go up to form the cloud, your water might actually contain some dust particles and stuff that are not very safe for you to drink. And therefore the idea is water treatment. Water treatment, like the one you have at the Bukit Barun water treatment plant, you need to treat the water to make it suitable for drinking. The water that we drink from the tap, we also need to boil it, just to be safe, to prevent cholera or whatever. Not that we have cholera anymore in Brunei, okay? The very last thing, you need to know about the different processes, first of which is sedimentation, then filtration. What is the purpose? So the process as well as the purpose of the process as well. You also need to use carbons. So this is present in your water filter. If you have a water filter at home, those things that look cylindrical, and then it's a 3-dimensional cylinder. You change it probably once a month when the water filter stops dispensing you water at a reasonable rate. Then you have to change it. Inside those filter is carbon, is black color carbon. As you know, it's like a black solid. It's got carbon inside, and that helps to treat the water even more. It removes the really bad taste and odor. So taste is how it tastes like. Odor is just how it smells like. The very last thing you do is you do chlorination. Chlorination means you add chlorine, and chlorine can kill microorganisms. You think about your swimming pool. Your swimming pool smells a bit like Clorox. That is because Clorox gives you chlorine, and you add chlorine to swimming pool, and that can kill microorganisms, harmful bacteria. That's the same thing we do in our drinking water. We don't add as much chlorine as in swimming pool. We only add enough chlorine to kill the microorganisms in our drinking water. Yeah, okay. If we put as much chlorine in our drinking water as we put in swimming pool, I'm sure you're gonna die from chlorine poisoning. Okay. Now the real last thing you're gonna do is this concept called desalination. If you're a marathon runner or if you exercise a lot, then one day you lost too much sweat, you go to the hospital because you got dehydrated. The first thing they do is they give you saline solution. So saline solution, when you go to the hospital, they pass this packet of a solution. Inside it's called saline solution. It contains salt. So desalination means remove the salt. Remove the salt. This is not so important in our country like Brunei, but it's actually very important in some other countries like Singapore. Singapore has a long-term problem with their water, clean water, because they're surrounded by South China Sea and they don't have the water from river and stuff. So what they do is they have to get the drinking water from the seawater, which, there is another way for them to survive in Singapore other than just buying from Johor, which, political issues can result in water being cut off and stuff. So not so important for us, but it is important in some countries where they need drinking water. If you don't have water for your people will die, okay? Now let's go through the actual content itself. It's not so tricky. The first thing we do is this kind of labeling apparatus. I show you this apparatus set up last year when we did separation technique. Last year, I showed you the experiment where we separate alcohol and water. But here, this could be a salt water. So it could be a seawater. Your seawater, which contain majority is salt and also water, and of course some other stuff as well. Now we know that your salt, sodium chloride, the salt that you put in your seasoning for your food, that has a giant ionic structure. Last year, you have learned Na plus and Cl minus. You know about sodium atom that give you Na plus and Cl atom that give you Cl minus. Can you have a look at your periodic table? I think pretty much everyone has a periodic table. Let me ask, is Effa there? Are you there, Effa? Probably Effa is not online. Are you there, Mukri?
Yes.
Hi, Mukri, do you have a periodic table next to you?
Yes.
All right, can you tell me the electronic configuration of sodium from your periodic table?
Sodium, Na.
So I know there is a symbol. What is the electronic configuration from your periodic table? So there's 2 electrons in the first shell. How many electrons in the second shell?
2, 8.
Now you're a neon. Have you reached sodium yet?
2, 8. 2, 8, 1.
Okay, so you go 2, 8, 1. So first shell, second shell, and then third shell. As you know, when they form a compound, this is going to lose the outer shell electrons, and then it's going to form the Na plus. Now it loses the outer shell electron. You lose the 1 outer shell electrons. You end up with just 2, 8 for the sodium ion. Now you're going to do the same thing for the chlorine. What can you tell me about the chlorine electronic configuration? When you have chlorine, can you find chlorine in your periodic table? What is the electronic configuration?
2, 7.
Are you sure it's 2, 7?
2, 7, 7.
Are you sure it's 2, 7, 7?
Yeah,
So 2 is helium. After helium is lithium. Can you count how many elements are there from lithium all the way to neon?
1, 2, 3, 4, 5, 6, 7, 8. 2, 8, 7.
So okay, so you know there are 8 groups in the periodic table. Yeah, 2, 8, 7. Don't miscount that. So the non-metals will gain electrons. You want to complete the outer shell. How many electrons do you gain to complete your outer shell?
1.
1. So when you gain 1 electron, you're going to have Cl minus ions. So that becomes 288. The ions now have fully filled out the shell. They give you NaCl, Na plus, Cl minus there. Anyway, strong ionic bond, high melting point. You're going to boil the simple covalent structure, which is the water molecule first, because you're just breaking the weak intermolecular forces, low boiling point for simple covalent molecules. These are year 9 covalent bonding topic. Okay, don't forget that. Well, something you all might want to be able to do is this dot and cross diagram. So oxygen has 6 outer shell electrons, like these 6 crosses, because oxygen is 2, 6, just like the exercise that Mukri just did. All of you should have a periodic table. So 2, 6, and then they form 1 covalent bond with hydrogen. So that is water. We are doing chemistry of water today. So it's very important that you are able to draw the dot and cross of water molecule. Single covalent bonds, 2 electrons being shared, 1 dot, 1 cross. The rest of the crosses are just the lone pair of the electrons not involved in bonding around the oxygen there. All right, so just to recap what I said earlier, so we never use tap water, for our real practical. Instead, what we do is we wash with tap water, but we also rinse with some distilled water, because distilled water is 100% pure water. This is the one that boils at 100 degrees Celsius. Our tap water does contain some impurities. And when you do have some impurities, they're not going to have a fixed boiling point or fixed melting point. That was part of your year 9 states of matter. If you remember your heating curve like that, your heating curve that looks like that, we know that pure substance has a fixed melting point, and a pure substance also has a fixed boiling point. But then when you have seawater or when you have tap water, these lines will not be fixed like that, because they will have impurities, and they will not have a fixed melting and boiling point, because impurities will result in a slightly different melting and boiling point there. Okay. On to the very, very important part of the lessons there, which is basically on how to produce drinkable water. This is called water treatment. So the very first thing is this follows step by step. So make sure you can spell each of these processes. Yeah. Sedimentation. So you have impure water, which has insoluble particles. Okay. So it has insoluble particles in there. So imagine your muddy water that come from river. It might be muddy or the water from Kampong Ayer, you know, you know how dirty it is, right? So, you know, it might have some solid in there, some garbage in there. So the first thing you want to do is you want to allow those things to settle to the bottom. Okay, when you have water and it's got suspension of solid particles which are insoluble, just let it settle. That is called sedimentation. Just let the insoluble stuff to settle to the bottom. Okay, once you settle to the bottom, then what you do is you will filter. Filtration in Malay word is called tapis. So what you do is you just remove the insoluble solid from the solution. But your solution is not clean yet. It might be colored. It might have some weird tests in it. It might have bacteria in it. So it's not clean yet. You just remove the solid. The next thing is called using carbon or pass it through carbon. This will remove the bad taste and the odors. If you have the water from Kampong Ayer, it's definitely got some urine and some bad stuff in there, okay, like sewage and stuff. So you want to remove the taste and the odors. Last but not least, your water is not safe for consumption until you can kill the harmful microbes or the harmful bacteria or the harmful microorganisms. We don't want to, you know, to have the whole country fall sick because of poor quality water. Okay, so we add chlorine. In case you don't know, chlorine is this element, Cl, but it does not exist as the element itself. Do we know how does chlorine exist as an element? Is Azwan there? Hello, is Azwan there? Okay, Azwan is not there. Is Fendi there? Is Afendi there?
Yes.
Hi, Fendi. Do we know if chlorine exists as an atom or as a molecule?
Molecules.
Okay, because it doesn't have a fully filled outer shell, so it does exist as a molecule. So there are two atoms of chlorine that form a molecule. What is that one word that describes two atoms forming a molecule? Do you know that one word that describes two atoms forming one molecule? When you have a molecule, you have two atoms forming a molecule. There is just one word for it. Do you know what is the word? Any idea, Fendi? I'll give you a head start. It start with this letter. It start with D. Any idea? Not much idea? Oh well, it's called diatomic. Diatomic molecule is part of year 9 structure and bonding. Yeah, so make sure you know di refer to two, the atom there, two atoms bonded together to give you a molecule there. All right, so the very last thing is desalination. So in desalination, we want to remove the salt. So this is reclaiming the drinking water from seawater. We can't do it, we don't have to do it in Brunei, but in countries like Singapore, as I mentioned, they do need to get the drinking water from seawater, and they do it by the process of distillation. But the proper name to get this drinking water from seawater is called desalination. If you just distill the seawater, this is called distillation, but desalination is just a very full name for that specific process. Remove the salt from seawater to get your drinking water there. Okay, in terms of what I just said, it's important for us to actually, go through a couple of questions to see whether we understand this concept or not. Yeah. All right, Kinawi, are you there? Hello, Kinawi, are you there? I guess Kinawi is not there. Is Wazin there? I saw quite a lot of names who have marked themselves as present, and I can't see who is present or not on Zoom. Yeah, so if you're there, please do answer. Is Watika there? Is Efa there? So I guess not a lot of people are there then. Masara, are you there? I should probably go back to my Zoom and see who is present or not. Seems like a lot of people are present. Not too sure if it's internet connection or whatnot. Are you there, Kinawi? Nope. Seems like a lot of people are not present. Okay. Well, let's go back to the few people I've asked before. Fendi, are you still there?
Yes.
Okay, so clearly it's not an internet issue. I don't know where the rest of the people are. All right, so why is carbon used in the purification of drinking water? Remember, we use carbon. We use carbon in our water filter. So what do we use carbon for? Do we use it to disinfect water, Effendi?
Huh?
Do we use carbon to disinfect water?
To remove the test and odors from the water.
Yeah. Okay, that's fine. That's right. What do you use to disinfect the water? We want to kill microorganisms. What do we use?
Chlorine.
Chlorine. So what do we do here when we filter out solid? What is the name of that process?
Apa ni tadi, Nek?
You want to filter out solids which are insoluble, right? What is filtration? That is the name of the technique. Yeah.
Filtration.
Okay. Now the next thing is desalinate the water. What does desalinate means to you? What is the meaning of desalinate? It's one word, right? What does desalination or desalinate mean to you? What are we doing during desalination? Oh, well, it's just above here. This is what you're doing. You're removing the dissolved salt from seawater. So you're reclaiming the drinking water from seawater. You remove the dissolved salt by distillation. Very important, yeah? You remove the salt. Desalinate, remove the salt from seawater by the process of distillation, which involve two processes. As we mentioned earlier, you have to boil, that is evaporation or boiling, and then you have to pass it through condenser. This is a condenser. It condenses the vapor back to the distillate, which is the liquid there. All right. So this is part 2. You can probably try this on your own, and then everyone can just, private text me later on your answer, and then we can just check whether you've done the correct thing there or not. Now let's go through this air quality and climate very quickly. We're supposed to go through just water, but this is a one-page thing. I just want to get it over with so that we can get through air pollutants in the next lesson. This is your lower secondary science. In lower secondary science, you learn that air is a mixture. You learn that air is a mixture, and air contains different substances. You have 78% nitrogen, which exists as this diatomic molecule. You have 21% oxygen, which exists as this diatomic molecule, 2 atoms bonded together. And you also have a mixture of noble gases and carbon dioxide as well. So you have 78% nitrogen plus 21% oxygen, that is 99% there. So you still have 1% made out of carbon dioxide. Inert gases are basically the group 8. The group 8 are the noble gases or the inert gases there. Nitrogen, group 5, triple bonds. They want to share 3 outer shell electrons. 1, 2, 3, 4, 5. They share 3 more there. 1, 2, 3, 4, 5 dots. They share 3 more there. They give you a nitrogen, 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 triple bond there. Oxygen, group 6. They want to share 2 electrons. So they get up to fully fill out the shell. They give you your oxygen, oxygen, double covalent bond. These are diatomic molecule. As we did mention earlier, 2 atoms bonded together to give you a molecule there. You also have carbon dioxide and water, but this amount of carbon dioxide and water in the air differs because of processes called respiration, as well as photosynthesis. Just as the very last thing I want you to think about, if you have a lot of people in the classroom, okay, we're gonna get people who will respire. So you're gonna do sugar plus, what does respiration involve? What does sugar react with? Sugar or carbohydrate, what do they react with? Are you there, Azwan? Is there Azwan? Hello? Nope. Is Azura there? Is Azura still there?
Yes,
So we
sir.
can't have much. Hi, Azura.
Hello.
Okay,
Yes.
so respiration, what does respiration involve? Have you done respiration in biology yet? Have you done this topic in biology? So what is the equation for respiration? What is the equation for? You are living right now, right? You are doing respiration right now. So what are you doing when you respire? sugar plus something give you something plus something. Any idea?
No.
Okay, do
No.
you know what photosynthesis is? Do you know the equation for photosynthesis? So you have no idea on respiration and photosynthesis. Okay, never mind. Andrew, are you there, Andrew?
Yes. Yes.
Andrew, can you tell
Yes,
me
sir.
anything about photosynthesis or respiration? You can tell me whichever equation you want. Any thoughts?
Equation of photosynthesis.
Uh-huh. You don't have to look this up, right? If you know it. Do you know the equation or not?
Carbon dioxide
Uh-huh.
plus water.
That is correct, because plants will take in our carbon dioxide and they react with water. What do they give you?
Give glucose and oxygen.
So glucose and oxygen. And we human being, well, the sugar there is basically the glucose. So the glucose plus our oxygen. We need oxygen to survive. We have food this morning, they get broken down to glucose, and your glucose is burning in the body. That's why your body is not cold like a dead, human being. The body is cold, your body is warm because you're burning glucose in your body, and that gives you carbon dioxide and water. Okay, so here, respirations is what you call exothermic, because that is combustion. That is called combustion. You learned in the last topic, combustion is exothermic. In your body, you are combusting food, you're combusting glucose that give you heat energy and allows you to continue, living on and on and on. Anyway, so when you respire, you give out carbon dioxide. When you have a lot of people in the classroom, your amount of carbon dioxide is going to be much greater than 0.03%. The amount of oxygen is going to be a bit lower than 21%, because a lot of people will do respiration in the classroom, crowded classroom, or when you go to a concert packed with people, the oxygen would be lesser than that. The carbon dioxide would be greater than that as a result of respiration. Okay, so obviously the plants, the more plants we have, the more it is able to absorb the carbon dioxide and remove the amount of carbon dioxide in the air, which essentially is actually considered a greenhouse gas that can cause global warming. And we'll talk more about that in the next lecture. Okay, just to summarize, nitrogen can be obtained by doing distillation, but this is distillation of air, which consists of these nitrogen, oxygen, argons that have different boiling point. That was what Bob couldn't get earlier. Distillation works because of different boiling point. You can separate even these two gases together by doing distillation because they have different boiling point. Oxygen, also distillation of air, and the rest of the gases consist of noble gases and carbon dioxide. Okay, so I think I'll just leave it there for today. So 20 minutes screen time and just a brief recap of what we did. We have done all of these distillations. We have done the separation of the particles, the insoluble particles. To remove the taste and odors, we use carbons. We add chlorine to kill harmful microorganisms. And in doing so, we already got our drinking water straight from the dirty water, which we treat our water. It's called water treatment. Don't forget the processes as well as what you use along the process. Desalination, more important in countries which have to get drinking water from the seawater. Left you with one question for you to do, so you can just text me the answer here. Private text me later on, and do try work one. So there's work one which I have sent out in the group as well, and you have until Monday to send in that work there. Okay, we'll just leave it there for today. So thank you, everyone. And let me just quickly take your attendance. It seems like a lot of people are present on Zoom, but not a lot of people seems to be responding. Okay. All right, that's it, guys. I'll see you guys on the WhatsApp chat where you will text me your answer and you will send in your work one, which is a 4-page work by, I don't know, by the end of today, I guess. Okay, anyone got any questions? If not, then feel free to leave the Zoom. Okay, thank you, everyone.
Thank you, sir.
Thank you, sir.
Bye.
Thank you,
Now
sir.
everyone respond. Tadi
you,
never
sir.
respond. Now everyone respond. Okay, bye, guys.